Hey everyone, it's that math magician, and on this video we're going to take a look at exponential equations, and more specifically, when we're given 2 points, can we determine an exponential equation? Now in the previous video, we were actually given the 0 term as one of those points, but for this video we're going to see what if the 2 points we're given do not include the 0 term. And just to preface this video, this is going to have a lot of algebraic skills involved. The explanation will be quite lengthy, but I hope if you stick with it, you'll be able to use this process with any 2 points to determine your exponential equation. So let's go ahead and dive right into an example problem for an exponential equation. Now we see here we're given 2 different points that lie on our exponential curve. The first point here is 2, 16, and the other point is 6, 256. And all we know is that those 2 terms there, those 2 points, are on the same curve. And our goal is to create an exponential equation that will go through both of those points. Now remember, this is the generic form of an exponential equation. Y equals a times b to the x power. And remember, a represents our y-intercept and b represents our multiplier. So when we're given these 2 points, those are the 2 things we need to find. We need to determine what our y-intercept is, and we need to figure out what our multiplier is. So we have 2 points, and we have 2 unknowns that we want to find. Now, if you watched the previous video, you'll remember that we were actually given the 0 term for one of those points, right? And if you're given a point where the 0 term is there, then whatever this number is for y, that actually ends up being your a term. But that's not what we have here for this example. Both of the 2 points that I have, neither are the 0 term. So now we're going to need to put in a little extra work to figure out what a and b represent. Now you'll notice underneath the points I have labeled what each point is for the x value. We see x equals 2, x equals 6, and we see their corresponding y values. When x is 2, y equals 16, and when x equals 6, y equals 256. So what we actually want to do is that since we have those 2 points, we want to create 2 different equations. If we can come up with 2 equations from those 2 points, it'll help us figure out what our missing a and our missing b term are. So to do that, I'm going to rewrite our generic form of our exponential equation, y equals a times b to the x. But instead of writing the y variable, I'm going to substitute in one of my y variables. I'm going to substitute in 16 because I know that y equals 16 when x equals 2. So do you see that I've created an equation using this point? Now again, I don't know what the starting point is or the a term. I don't know what the multiplier is, but I do know that I will have an x value as my input of 2 with an output of 16. Now I want to do the same thing again. I'm going to rewrite that equation one more time, but again, instead of leaving this as the y variable, I'm going to change that variable to what the other y equals, and that is 256. Well, y equals 256 when x equals 6. So what I've done here is I've created 2 equations. They both are involving those 2 points, and I know that both of the a values and the b values are the same for those 2 equations. Those 2 points lie on the same curve, so that means that their a values must be the same and their multipliers must also be the same. Now, when you have 2 equations and 2 variables, that just means we have a system of equations, very similar to when we did that with our linear equations. And what we want to do now is see, can we use one of our methods? Remember, we have equal values, elimination, substitution. Can we use one of those methods now to help us solve for either a or for b? Well, I'm going to let you know right now, I want to use equal values method. And remember, equal values is when we use that when we have 2 equations that are equal to the same variable. So we need to get both of these equations equal to the same variable. And I think there's a very easy one we can use, and that is our a variable. So let's go ahead and solve both equations here for a so that we are able to use our equal values method. So looking at this equation on the left, I want to solve for a. I want a by itself. Well, right now a is being multiplied by b squared. So to get rid of that b squared on both sides, all I will need to do is just divide both sides by b squared. If I do that, the right side, those will cancel and become a 1. So then on the left side, I'm just left with a equals 16 divided by b squared. And now we know what a equals. We know that a equals 16 over b squared. We're going to leave that there, and we're also going to do the same exact thing on this right equation. I want a by itself. Right now a is being multiplied by b to the 6th power. So I will just need to, on both sides, divide by b to the 6th power. I do that, and these b's on the right will cancel, just like our left side. And I'm left with a equals 256 over b to the 6th power. And we see how I've solved both equations there now for a. I know that a equals 16 over b squared, and I know that a equals 256 over b to the 6th power. So since I know both of those terms equal a, I can now set those two expressions equal to each other. That's the equal values method. I'm going to write now that 16 over b squared equals 256 over b to the 6th power. Now what I need to do is I have two fractions equal to each other. I only see one variable now. I only have the b variable. I can definitely solve for b now just by using some arithmetic skills. Remember, when fractions are equal to each other, what we want to do is we want to cross multiply. So I'm going to go ahead and multiply the top and the bottom of this equation. 16 times b to the 6th power will become 16 times b to the 6th power. On the right side, we're going to end up with 256 times b to the 2nd power. So we are on the way to solving this equation. Now again, I need to get all my numbers to one side. I need all my variables to the other side. Well, I see that I have b squared here on the right side. I want to move that b squared over to the other side. So to do that, I will divide both sides by b squared. When I do that, when I divide both sides by b squared, the b's on the right cancel out. On the left side over here, on the right side, I'm just left with 256 because those b's on the right are now gone. On the left side, I still have 16, and then b to the 6th divided by b to the 2nd power. Remember, that's a law of exponents problem. Whenever you have a variable on the top of the fraction and the bottom of the fraction, and they're the same variable, we both have b's here, you just take those exponents and you subtract them. So 6 minus 2 leaves us with b to the 4th power. So now I have b all by itself. I'm so close to finishing this problem. The last step I need to do over here is I need to divide both sides by 16. If I divide both sides by 16, the 16s on the left cancel. So then on the left side, I'm just left with b to the 4th power equals 256 divided by 16. Well, that just equals 16. So I am so close now. I almost know what my multiplier is. I see that b to the 4th power equals 16, but I don't want b to the 4th power. I want b to the 1st power. So to do that, to get b all by itself, all I need to do is take 16, and I need to take the 4th root of 16. I'm taking the 4th root because my exponent here was to the 4th power. Had it been to the 3rd power, I would have done the 3rd root. Or if it was the 2nd power, I would have done a square root. But because there is a 4th power there, we need to take the 4th root of 16. If you don't know what that means what number times itself 4 times will give you 16. That's a little confusing and you don't know that off the top of your head. use a calculator. I'm going to use the free online calculator from Desmos.com to help me solve for b. So here's my Desmos scientific calculator. I see here that I can use the square root button right here, but instead I need to use the n root button. The n root button will let me switch that to the fourth root. So I go ahead and click on the n root button, and then I see here I'm highlighting in the root button there. I want to now press the 4 to represent the fourth root, and then I need to switch over to inside the square root there, and now I can type in 16. I type in 16, and I see that the fourth root of 16 equals 2. So the fourth root of 16 equals 2. I now know that my b term, or my multiplier, is 2. Did it require a lot of work? You bet it did. A lot of work. But if you look there, the only thing that I'm doing is really just dividing to get variables by themselves. And over here, I had to cross multiply those two fractions. So it looks complicated, but the math behind it is really just multiplication and division. So now that I know my b term, all I have to do now is figure out what a equals. Remember, we have two equations here that represent a. I get to pick which one I want to use now. It really doesn't matter which one I use. So I'm going to go ahead and pick the one on the left because it looks a little easier. And so for that, I'm now going to write that I know that a equals 16 over b squared. But I know what b equals now. We solved for b. b equals 2. So instead of writing b squared, underneath that, I'm going to change b to a 2. So it's just 2 squared. I can now solve that for a and figure out what my y-intercept is. So a is going to equal 16 over, let's see, 2 squared. 2 times 2 makes 4. So I know that a equals 16 divided by 4. That just ends up equaling 4. So I have now figured out both missing terms for my exponential equation. I know that I start at 4. I know that my multiplier is 2. So the final thing I need to do now is just create my exponential equation with those two terms. I now know that a here is going to be represented by a 4, and I know that my multiplier is 2. I put that to the x power, and I now have created an exponential equation that passes through the 2 points 216 and 6256. It is y equals 4 times 2 to the x power. Again, is this very heavy with the math? Yeah, I agree. That's a lot of math skills that we have to use. But if you follow this process, you will always be able to figure out your exponential equation when you're given 2 points. It's that math magician, and I'll see you on the next video.